Welcome to this brief video about OpenAI's new code interpreter function that was released on the 7th of July. In this first example, I'm going to use data from PharmAdvisor, which is built upon the FDA adverse event reporting system, and in this case describes a patient taking a number of medicines after a kidney transplant who then developed tuberculosis, subsequently developed the side effect of thrombocytopenia, and the physician wanted to know which drug might have caused the problem. So in this case we can see that the PRR value, which is a measure of disproportionality, shows that this combination of drugs was 9.85 times the background rate for all other drugs. We're going to use this data because it gives us some numbers we can check the output from code interpreter against. It also means we can look at things like the PRR rate for drugs in the same class, so that the clinician might choose, so here we have that combination, but the clinician can also look at the values for other drugs, and again we can compare this to code interpreters evaluation of the data. So what I'm going to do is download this data in a slightly modified form so that we can use it in code interpreter. The first thing to say is that when you're uploading data to code interpreter, it's best to go through your data, trim it down and get rid of any information you don't need. Then make sure the headings are clear, because you'll be using those in instructing code interpreter. Once you've cleaned up your data, you can upload it to code interpreter, which is only available if you've got a subscription to ChatGPT+. You can then use the GPT-4 connection, select code interpreter, and upload the file that we've just curated. So that takes a few seconds to load. I think the file limit's about 10 megabytes at the moment. So we can now start exploring and inquiring about this data. It's important to remember that you are uploading your data to OpenAI, so be careful. And now we form a query. With the file now uploaded, I'll input a query, and what I'm trying to do is to replicate the query we had on PharmAdvisor, which is for a patient suffering from tuberculosis, and the clinician felt that the side effect she developed, which was thrombocytopenia, was an ADR, and wanted to know which of the medicines the patient was on could be responsible. So the query needs to be carefully thought through for a variety of reasons, which I won't go into, but you need to be very clear and succinct. So we're telling it we want to identify the thrombocytopenia side effects based on the proportional reporting rate values. These are the drugs, and these are the outputs that I want. So we've loaded the data, there's our query. We'll let the system start its analysis. Look at that. Now what it does is to load, once it's loaded the data, it starts using code interpreter to analyze the data, and while it's doing that, it's generating Python code, which you can see here. So it's actually writing the program that it wants to resolve our prompt. And it'll take a few seconds. It's finished working. We'll hide that. So it's now going through the query that we'd set. Right, so it's now coming back with a reply. It's putting it into a table because I asked for that, and it's giving me a ranked order of PRR values for these drug reaction pairs. So the reaction is thrombocytopenia, and these are the drugs the patient was on. And when it's finished, we can now compare this with the data that we used in PharmAdvisor. So if we take the drug with the highest PRR, that is, it's 9.85 times higher than all other drugs in the database. It's this combination of isoniazid, pyrazinamide and rifampicin, which I've also included as individual drugs. We now look at the PharmAdvisor. We see 9.85 is the correct value, and the case count of 16 is also correct. Now, because the code interpreter is built on ChatGPT or GPT, it continues this conversation mode, so I can now ask follow-up questions. And another very useful function of code interpreter is its ability to create charts. And in this case, I'm asking it to chart the PRR values for the drug reaction pairs, so that I could include these in a presentation, for example. And there we have it. It's created that chart out of nowhere, really, and shows the PRR values quite effectively. I'm now going to ask it another follow-up question, which is built around the idea that other drugs within these drug classes could have lower PRR values. If I wanted to challenge one of the drugs, say swap it out and then replace it with a drug within the same class. So I'll ask it to do that. I won't go through it, but this data essentially is grouped, was selected to contain all the drugs in the same ATC classes as the patient's drugs, and also we looked at reactions according to the structured MEDRA query. So they're grouped. And I'll show you in a minute how we can ask for other drugs. So I'll ask that question. Again, it's important to be very clear and precise about what you want the system to do, so your prompt needs to be very accurate. So here it's gone off and it's found the same data, PRRs for these drugs. It's got the frequency as appears in the data sheet, but it's also looked within the same class of drugs. These are drugs that treat tuberculosis, and it's found ones with the lower PRR values. So this could offer a clinician an alternate medicine for getting rid of the thrombocytopenia and treating the patient's tuberculosis. And in this second example, I'm going to import some data from the prescription cost analysis data that's published by the government on the web to try and get a view of what drugs are being used and what their cost is. So I loaded the data, and now I'm going to ask it my question, which is basically asking it to summarize the cost of drugs within a particular group, anticoagulants and protamine. Now this data is very low level in the data, so it's going to have to do some work to group things together into that anticoagulant grouping. I then want it to give me totals for the quantity of prescription items, the net ingredient cost, and then produce a chart. So let's let it go. So here is the output for this group of drugs, anticoagulants, and it's grouped together and summated all of the quantity values for this particular date, which was March 2021, and broken it down by quantity and total net ingredient cost. So my follow-up question will be to ask it to do a calculation. So this is data that's not in the data set. The system has to work it out for itself. And I want it to calculate the net ingredient cost per item. I per unit of the quantity. So it's finished the calculation, and it's made an error which it will correct. It hasn't imported one of the Python libraries that it needs, so it's going to correct itself and then rerun my calculation. Well, we all make mistakes, but now it's actually worked out the cost per unit. So it's basically the net ingredient cost divided by the quantity to give us the cost per unit. So again, that data is not in the table. It's worked it out eventually and is giving us information that we can use, and it does it very quickly. So I could go on to ask other questions, and this really is the key for me, which is you don't have to sort of structure questions like you would with a normal database. You can just go ahead and figure out what it is you want to ask it. So my final question is to get it to produce a chart and display that to me. You can also use time series data, which we haven't got here at the moment, but I'll work on a demonstration of that so that it can actually then work out trends and projections, which again is very useful. So there's our chart. Again, you can copy that straight into a presentation, and you can also see that it gives you some slightly useful information. Just to show how versatile this is, I can change the group that I'm investigating. So I'll just ask it to repeat analysis for antiplatelet drugs. So it's now replaced the previous grouping with the antiplatelet drugs. It looks up those in the file, does the calculations, and then presents us with the response. So this is for anyone who's ever worked with large data sets and trying to figure out solutions quickly, this is quite remarkable, and can allow you to really explore your data very, very simply. But as I say, curate the data and normalize it so that the headings are clear and not too overly complicated. Some databases are. Make sure that your prompt is well structured, although you can always go back and change things. And I hope this helps you save a lot of time. Thank you for watching the video. I hope it's been of use. This is a rapidly changing area of development, as I'm sure you can appreciate. So whilst we keep abreast of all the various developments, it's clear that applying these to organisation requirements isn't always clear and straightforward. So for example, with Code Interpreter, there are many areas where it can be used to improve efficiency and speed up the actions and functions of staff. So what we're working on at the moment is a series of training courses which will be available shortly, which we will probably produce as webinars, or we can do as in-house presentation and training courses for companies. And what we're doing is trying to split it up across the specialities within companies, got a few listed here, so that the content is precisely tailored to those groups. We'll be publishing more information about these courses shortly, but if you want to get in touch, there's my contact address, and once again, thank you.